Hi everyone, welcome. Hope you guys can hear me. I know it's a small crowd, so we can have more of an intimate conversation. Thank you, thanks for taking the time to join this session. And I know you're all coming from lunch, so I have a tough task. I want to make sure that I don't make any of you doze off. Hope you have your coffees. My name is Balaji Krishna. I'm part of the HANA product management team. And in today's session, I'm going to be talking about SAP and big data. What are we doing with Hadoop and how it works with SAP's own data platform, SAP HANA. And I'm hoping most of you got a chance to listen to the keynote that our CTO delivered earlier this morning. He talked about, at a very high level, what the motivations are, what we see from our customer landscape. And I just want to take you guys through a journey of where we started, when we started, and some of the things that you can look forward to in the future on what SAP is doing from a Hadoop standpoint and how we are embracing that Hadoop technology as part of our big data platform. So in terms of agenda, I won't go too deep into the big data overview. Obviously, all of you know about big data and what it is. I'll introduce you to the big data solutions from SAP. Go a little bit deeper on what are the different connectivities, how do you connect SAP HANA with Hadoop, what are the reasons, why would you want to do that, and some customers who are trying to do this, who have achieved this, who are in production, the different kinds of connectivities using the Spark, Apache Spark layer, Hive layer, and direct access to the HDFS layer. We also have within the SAP data management portfolio of products, we have a streaming product similar to Apache Storm or Spark Streaming. Again, we have this product almost more than 10, 12 years. Customers are using it, so just kind of introduce you to SAP's Lambda architecture, how we are kind of adopting that Lambda architecture when using a real-time streaming capability. Also introduce you to some of the other components within the SAP Big Data portfolio of products, primarily analytics. It's one thing to store and process the data from a data platform standpoint, but you also want to have the analytics visualizations. So just touch upon what analytics and predictive capabilities that we have within the SAP portfolio of products. And finally, introduce you to some use cases, real live customers who've been doing this integration, who've been using this big data, using HANA and Hadoop. And we'll have a Q&A session at the end of the session. And I'm also going to be available in case we run out of time for Q&A. If you have any questions, I'll be available after the session. We can go outside and talk about it. So big data is gaining momentum. Again, 50 billion. There are numbers which show a lot more than that. But obviously, as we can see, just from a Hadoop conference standpoint, in terms of the number of attendees, number of customer sessions that we are hearing about, great references this morning from TrueCar. Obviously, the momentum is gaining, and we're seeing that it's no more a myth, right? Again, talking about just pure Hadoop from a platform standpoint where you're consuming the data. This is going back to digitization of the economy. Companies across the globe, across the different industries, and again, SAP has a strong footprint across the different industries. We work with close to 20 different industries. We have solutions on our application side, the ERP applications, to around 20 different industries. So what we are seeing is this digitization of the economy is impacting across all the industries. What that means is they are capturing newer kinds of data which they were not even thinking about in the past 5 years, right? And with this, obviously, they want to have a more cost-efficient way, most optimal way of storing that data, processing that, and gaining insights out of that data. So this slide kind of talks about where it's heading from a mid to long-term standpoint. So 2020, it's going to be more than $50 billion. And we also heard some stats in some of the keynotes that we heard over the past 2 days. Obviously, the challenges, you have a lot of data and it's scattered across your landscape, right? So you have IT, which is managing the data. You have line of businesses who are capturing some new kinds of data. So there is confusion on what data makes sense. A lot of this is still batch oriented, so you don't have the real-time responses when you're interacting with a lot of Hadoop data, although some of the things that are coming out from Apache Spark standpoint or streaming is providing some of these real-time capabilities, but it's still primarily batch-oriented. And there are technology limitations. Some of the stats that we've been hearing from analysts is it's a loss of around 237 billion across the different corporations, 200 global companies, over 10% loss in productivity and loss in revenue for these Fortune 500 customers. Having data is one aspect of it, but gaining insight is another one. So it's not just about storing all this data. Yes, now I have a great platform which provides a lower cost per terabyte. I can pull in all the data. I can capture all these new signals. Once I have that, how do I make sense out of it? How do I tie that data which I'm consuming from a new digitization standpoint? How do I tie the data with my corporate data? What's that contextual data that I'm looking at from a point of sale standpoint for a retail customer, or from a revenue standpoint, and how can I tie that to a sentiment that a company is looking at from a product launch standpoint? So that is the value proposition that SAP is providing. How do you bring in these large volumes of data, petabytes of data, which is in your Hadoop, along with data that is coming from your corporate world? It could be SAP data, non-SAP data, which is stored in HANA. HANA is an in-memory database system where you can run transactional applications. So SAP ERP, which is one of the most commonly used transactional application, is currently running on HANA. We have over 60,000 customers who are running SAP ERP on HANA. How do you bring this contextual data? How do you bring this corporate data, combine that with your unstructured data, semi-structured data, or data which is in your data lakes? How do you combine these? That's the value proposition that SAP is providing. Obviously, the key thing that SAP is bringing to the table is the standardization. Yes, you can build your reports, you can build your dashboards, you can build these predictive algorithms purely on Hadoop, but there is a huge TCO involved when doing this, with the number of developers that you have to hire, with the complexity that's involved. And obviously, a lot of partners who are in this conference are trying to eliminate a lot of those complexities. But again, when it comes to providing that standardization, a single platform, single vendor with whom you can interact with to bring these two different kinds of data, the corporate data and your social media data, sensor data, IoT data, combine those two, SAP can provide that standardization. And SAP is not new to open source. We've been involved in open source. It's a company which has been around for 43 years, 40 plus years. We've contributed to several open source projects. Hadoop is one of the new ones that we're starting the journey on. And obviously, a lot of it is what the customers are asking for, right? It's not like SAP woke up one day and said, hey, let's do Hadoop. Absolutely not. It's going back to these customers who already had SAP systems in their landscape for 40 years. These customers were coming back to us and saying, hey, I'm thinking about Hadoop because of all these reasons. Please advise, which Hadoop distribution do I have to put in my data center? Obviously, there's a lot of myth around the data center readiness of Hadoop. How reliable is it? What is the trust factor in the Hadoop data? So please advise us on how we can go about this Hadoop journey. And this is when we kind of opened up our arms to ensure that we are providing support to our customers, but also at the same time we are contributing to the open source community. And we've started the journey. We hope to do more just purely from a Hadoop standpoint, from Apache Software Foundation standpoint. And in that aspect, obviously, we are closely working with Hortonworks, where they're guiding us through some of these principles initially. So now covering the big data solutions on the SAP side, what are the different big data solutions? We start off with in-memory database that SAP has. And again, going back to what Quinton talked about at the keynote today, SAP HANA platform is at the center of SAP's data management portfolio. But it doesn't revolve only around that. We completely acknowledge that, yes, definitely there is an opportunity for us to work with Hadoop NoSQL vendors where we can bring in the data, large volumes of data that can be combined with data which is sitting in HANA. So purely talking about HANA, HANA is an in-memory data platform. It's a columnar database. It allows you to store large volumes of data, and because of the columnar fashion, the data is compressed. The data completely resides in main memory. So it's not a caching mechanism, it's a pure in-memory database. Data is first loaded into HANA, and the processing is done on that data, which is primarily in HANA. The other key aspect of HANA is we've combined multiple engines into this HANA platform. So just as the revolution was happening on the Hadoop stack, there was a revolution happening on the in-memory side as well, where different companies, and SAP being one of the pioneers in this in-memory database technology, we were building things like predictive capabilities on the HANA platform, spatial capabilities. What that means is enabling the database, the in-memory database, to be able to support all these different kinds of data types. Why did we want to do that? In order to reduce the complexity. Today, if you look at some of the other platforms, the traditional relational databases, if you want to do a geospatial processing, you have a separate geodatabase. So obviously, there are multiple copies of the data, multiple databases that you have to manage, install, administer, upgrade. With HANA, you have a single platform where you can combine all your data, your structured data coming from SAP systems, non-SAP systems, bring it into HANA, combine that with other unstructured data, semi-structured data, geospatial data, and make that data available for the different processing engine. So enabling the different IoT scenarios, think of smart cities, or think of the predictive maintenance capabilities. So all these capabilities, using the HANA's platform, you can take advantage of HANA as an in-memory platform, but as we are growing this data, since the entire data is in main memory, there is a threshold, obviously from a customer TCO standpoint, where they're calling the shots on, okay, it doesn't make sense for me to go beyond 20 terabytes on in-memory. Yes, this 10 terabytes of data for a specific customer needs to be in memory because they have those kind of SLAs, or they're running a transactional application like SAP ERP. But beyond that, when they're going beyond the 10 or 20 terabytes, they're looking at, okay, how do I take advantage of Hadoop? And once I put the data, how do I use the same kind of development capabilities that I'm using today with HANA? How do I extend that? Just because I have data in Hadoop, I don't want to be able to look at the Hadoop data in a different way. And now if I want to join it with HANA, there's a new development life cycle that has to be learned from a developer standpoint. We are reducing all that complexity. We are kind of masking all those things, where when a user comes into HANA, we provide these tables that are available in Hadoop as a virtualization model. So what we provide is this virtualization capability where HANA can pull the data that is coming from Hadoop, again, any distribution of Hadoop, as a virtual table, combine that with the data that's in HANA, and then make that available for BI consumption. It could be any of the BI tools, or it could be applications that customers or partners are building on top of these platforms. Absolutely. So the question is, if you folks didn't hear, is that development work completely transparent? That's what you're asking, right? If I'm building a data model, is it completely transparent? As a BI user, will I not know that this data is coming from Hadoop? Yeah, absolutely. And that's what we are trying to achieve. For end consumer who's consuming it through a handheld device, it's completely transparent. And obviously, there are some limitations when it comes to what is the volume of data that you're bringing in. Even in terms of the volumes of data, assuming that you have larger volumes in Hadoop compared to HANA, how do I do some kind of optimization so that smaller data set is moved between the two layers? We have capabilities like caching on the Hadoop side, and I'll cover some of those things in the future slides. But absolutely, the idea is, as a BI consumer, it's completely transparent. As a data modeler, absolutely, you need to know where the data is, because based on that, you're modeling the data to optimize the queries, so that the query optimizer behind the scenes knows exactly what kind of pushdowns has to be sent to that remote source, which is Hive or Spark, whatever the interface is that it's connecting to. If you don't mind, I'll just go through the slides and we can do the Q&A later. Thank you. So as you can see, we're not limited only to Hadoop, HDFS, but we're also working with NoSQL providers. So, so the Cassandras and the Mongos, we have connectivity that's built using HANA's data virtualization layer. For some of these, we use the Odbc drivers that Simba provides, so we depend on the Simba connectivity for several of these remote database connectivity. So going a little bit deep, and again, I don't want to bore you guys with too much HANA, but we have this YouTube channel called Hana Academy for folks who are interested in what SAP is doing in terms of databases, where in-memory technology is going. I definitely recommend you to go to Hana Academy, and you can read up all the great stuff that Hana has been doing. But primarily, like I mentioned earlier, it's built completely on in-memory columnar structure, and dynamic turing is one of the components where we're looking at, you have too much data in HANA, you want to move some of the data into Hadoop. So what are the rules that you want to apply, say on a table level, to move parts of the table into a different layer? In this case, it could be Hadoop as your tiering layers. That's one of the capabilities that we are building, we're providing to our customers. The Smart Data Access, Virtual UDF, those are connectivities that today we have with HANA and Hadoop. Primarily when it comes to how do I bring data from Hadoop, but I'm not storing it in HANA because I'm buying HANA based on how much memory I'm using. So I want to virtualize the data. We have customers in retail, high-tech industry who are already using these kind of capabilities, gaining knowledge, gaining advantage out of this capabilities based on Smart Data Access, Virtual UDF. Some of the other things that we have, things like Data Warehouse Foundation, or smart data preparation, where we're using some of the capabilities like data lifecycle management, which allows you to build these rules. So you're looking at a specific table and you're saying, based on this rule, I want to move my data from in-memory to disk-based architecture, so from HANA to Hadoop. Smart data preparation provides you the capabilities, again, when you're building these ETL models as a business user, how can you provide input for those ETL jobs or ELT jobs when you're as part of your data services or data preparation capabilities. So the strategy that SAP has in terms of working with the different Hadoop distributions is we're open to all Hadoop distribution. You see Databricks as well, so we have a very good offering on top of Apache Spark when it comes to how can we take advantage of the in-memory capabilities that Databricks has. Obviously, HANA's in-memory is available for transactional system and a lot of data mart capabilities that SAP has, SAP customers have, but we also have Databricks who's coming up with Apache Spark and all the things around in-memory processing for Hadoop. So how can we take advantage of some of the things that they're providing and also work with the different distributions here. So definitely we'll have to call out Hortonworks on some of the engineering co-innovation that we are working on. And again, like I mentioned earlier, we have close partnership from Hortonworks engineering standpoint in terms of how we are building these connectivities between the two layers, and in the future, what are some of the things that we want to achieve purely in terms of interactive SQL or bringing enterprise analytics to the Hadoop world. Some of the things like I want to do OLAP on top of Hadoop. SAP has been doing OLAP for 30 plus years. There's a lot that we can offer to the Hadoop world, especially when you're looking at, I have a bunch of files, it could be a log file, it could be a Parquet format. How do I do OLAP on top of that? So those are some of the things that we're working on, and we're closely aligned with Hortonworks on what is possible, what's not possible, how do we sit within that ASF, Apache Software Foundation framework when we're delivering some of these capabilities. And the other important thing is the Atlas project, where we recently signed up as a committer for the Atlas project to provide SAP's knowledge, the background that we've had in terms of data governance. Data security, metadata management, these are important topics. And with the due respects to the gentleman who shared this morning at the keynote about enterprise capabilities, absolutely you need to have the enterprise capabilities. Yes, there are some companies who can do without those enterprise capabilities. They can be the early adopters, you can go and adopt something, but when you want to scale that, when you want to scale it across 10,000 employees in an organization, or even beyond that for your partners, you need to have some of those enterprise capabilities, and that's where SAP is signed on to be one of the major contributors for Apache Atlas, and we look forward to that engagement with Hortonworks. So when it comes to the data platform, HANA data platform or SAP data platform, including Hadoop, what we have today is a three-step approach or three-tier approach, and in some cases it's a two-tier approach. We have SAP HANA, which is in-memory. Typically the data is in memory, so we're talking about zero response time. There are scenarios where customers need these zero response time, and I'm not talking about sub-second, but zero response time kind of thing. So real-time data which is flowing in, you want to be able to act immediately on those that data. You want to take actions based on that data, which will have another loop into your transactional system. So it's insight to action kind of thing, where you have new data that's coming in and you're acting on that data from a systems of engagement standpoint, and that is fed back into your ERP system. We also have another tier within SAP. It's called HANA Dynamic Tiering. It uses some of the components that we had from SAP Sybase IQ standpoint. So IQ is another in-memory, is a columnar database. What we provide with HANA and Dynamic Tiering is a single layer where you can do your install, manage, administer, monitor all your assets, the different nodes that are available in the cluster. And with dynamic tiering, we provide the ability where you can tier your data to a warm node. And beyond that, when you have, again, when we're talking about zettabytes of data, obviously Hadoop comes into play. There are several customers who have eliminated that green layer. So they already have a Hadoop system, and they're looking at, I just want to have a two-tier approach where I have HANA and Hadoop. And for Hadoop, obviously, we have that infinite storage. You want to store your raw data. Several scenarios where you have your kind of pseudo data warehouse, if you will, and we're working with several of those customers where they're trying to build some of those data warehouse capabilities on Hadoop. They've had some challenges, so we're providing that bridge between, okay, I have my data lakes, I want a data warehouse, how can you achieve that using HANA, and how can we interconnect both those, provide a layer which delivers an optimized way of data movement between HANA and Hadoop, as in specific cases where you're trying to access data from HANA, or several scenarios where you're trying to access the data from Hadoop. For example, in a data scientist kind of workflow, you're using Apache Spark, you want to do some kind of a machine learning algorithm, but for that you need some data that's coming from your corporate world. So SAP HANA data is exposed as a virtual layer through some of the capabilities that we have with HANA, and you use that corporate data, consume that as part of an Apache Spark application that's built on data that's sitting in a HDFS or a Parquet format. So in terms of the different connectivities, again, this slide is, you have a lot of arrows, but the primary idea is once this slide reaches to you, you know exactly what are the different connectivities that you have between the two platforms, between HANA and Hadoop. We started the journey with data services where it was pure ETL. I have data that I want to load into Hadoop, or I want to load into HANA, and then I have data that I want to load from HANA into Hadoop, some cases the other way around as well. But beyond that, what we provided is Smart Data Access, which uses the data virtualization layer. So this uses the Odbc drivers. So the scenario is you have your Hive tables, and you expose those Hive tables as a virtual table for HANA's calculation engine. Typical data modeling environment in HANA is you use this Web IDE tool. So it's a browser-based tool, or you also have an Eclipse-based tool. And in that data modeling tool, you are bringing tables that are resident in HANA. So these are tables that are primarily stored in HANA, and you're combining that with data which is stored in Hadoop in Hive. So you already have these Hive structures built in. You join those using HANA's calculation view, and then make those available to your consumption for BI. That's the integration using Smart Data Access and the Odbc driver. And last year, we introduced this virtual UDF function, virtual user-defined function. The primary motivation for this was to eliminate that Hive interface. Obviously, Hive is maturing today with 0.14, but what is happening in the past, 0.9, 11, 12, there was a lot of limitations in terms of how performant is it. And that's where SAP went back to provide the solution where you can directly connect to HDFS data. So you can eliminate the Hive layer, you can directly talk to HDFS, and you could do that using the virtual user-defined functions. So this is something we released last year, primarily for specific customers who are looking at some kind of binary data that they wanted to combine that with HANA. You have the ability to execute these virtual user-defined functions, which invokes a MapReduce job that's already written on the Hadoop side. We also have capabilities using the smart data integration. This is another EIM or ETL kind of usage where we have SDI, smart data integration adapters for Hive using the JDBC layer. So the smart data integration is a information management layer which is built inside HANA. So you have a single platform. Again, it goes back to that reducing the layers. You have the HANA platform. You use HANA platform to do ELT kind of processing. Again, it doesn't make sense when you're trying to bring the data from Hadoop into HANA, but the other way around, primarily when you're using HANA as a target and you want to load data from different other data sources. It could be Teradata, Oracle, or even flat files like it could be a Twitter feed. You have the IM information management features built into HANA that take advantage of the connectivity with Hive using JDBC layer. So I touched upon this. Primarily, this is the data services similar to Informatica kind of thing where you're using an ETL tool to move data back and forth between HANA and Hadoop. Smart Data Access is the data virtualization layer. And again, what you see in the industry from a pure data virtualization standpoint is there are several pure play vendors who are trying to achieve this, who are trying to provide these capabilities. But the whole idea with HANA is this is inbuilt into the platform. So you don't have to go and procure a separate license for a composite or a Donado. This comes as part of your HANA license for customers who already have HANA. So you can use the built-in data virtualization capabilities, connect to different sources, not limited only to Hadoop, but also to other relational data sources. So if you have data that's in Teradata, Oracle, DB2, you can connect to those, bring those as a virtual table, combine that with data which is in HANA, and make them available for your consumption. From a Hadoop standpoint, we have the Hive Odbc driver. Again, we connect with all distributions. What that means is we have customers who are using Cloudera, using MapR, Pivotal. Obviously, Pivotal is going to be Hortonworks as part of the open data platform, but we still have customers who are using Pivotal and, of course, Hortonworks as well, which is one of our predominant customers where a lot of our customers are using Hortonworks distribution. The whole idea with Smart Data Access is it's not just passing some query to the remote source, but it's how do you optimize that to ensure that the right level of aggregation is happening on the Hive side and you're bringing the smallest data set that can be combined, that can be joined along with HANA data. So the intelligence in that is built into some of the features that we refer to as join relocation or query relocation, where depending on where majority of the data is, we push the processing to that layer. So for example, one of the things that we're coming out with in SP10, that is the latest release of HANA, which is going to be available end of this month, is this feature called join relocation for Hadoop. And the scenario that we worked with several customers where they're looking for this is you have a join where you have a smaller data that is in HANA, obviously much larger data in your Hadoop side. How do I push that join to happen on the Hadoop side? We're using this join relocation technology, and we're using the connectivity to Apache Spark to be able to kind of mimic HANA RDD, if you will, on the Spark side. So you can expose that HANA data, which is a calc view, you can expose that to Spark and do the join on the Hadoop side. And once you've done the join, you have a much smaller data set that needs to be made available for HANA, which in turn can be consumed through a BI application. So those are the optimizations that are built into this virtualized layer. So it's not just about providing connectivity, but it's about how do I provide the most optimized way of combining these two data so that you still get that sub-second response time or seconds response time when you're combining data from these two different platforms. And I refer to the caching mechanism, especially when we're working with Hadoop. One of the common questions that we get is when you're combining data with HANA, which is pure in-memory system, and Hadoop, which is in most cases, or at least in the past, most cases were batch-oriented. How do you kind of handle the responsiveness, the latency issue? So what we provided is, on the Hadoop side, once you know what is the data, so you have a MapReduce job that you're executing and you know the data set that you want to join with HANA, that data can be stored as a materialized view on the Hive side. So after you executed your MapReduce job, you're storing that data as a Hive result set, which is being joined with data which is in HANA. So that kind of helps in negating some of the performance issues that Hive had in the past. And it also enables HANA to be able to present the data set faster to the BI consumer, because again, when you're combining these two different platforms, there are some performance issues. So we're trying to use the cached data set. And obviously, once we have this caching enabled, the question is, if you're using cached, then it's not really real time. Absolutely, it's not real time. And in terms of the caching, we have parameters where you can define, based on your SLAs, how long the cache is going to be available before you have to refresh it. So just a different diagram of the different connectivities, and I want to highlight some of the things that are coming as part of SPS 10, which is the Spark SQL adapter. So in the past, we were using the SQL Odbc. So again, a Simba Odbc to connect to Spark using the Spark SQL. Now what we have is we built a Spark adapter that is going to be installed on the Spark side. So we are going to use that RFC connection between SAP's own Spark adapter, which is sitting on the Spark side, and use that as a communication channel for moving data between the HANA and the Spark platform. So, and again, Spark works on the data which is on the HDFS, so you still have that full connectivity between HANA, Spark, and HDFS. I mentioned about the joint relocation capability. This is another important feature that we are delivering, again, to primarily address some of the customer requirements that we had around being able to speed up this data processing. And we also have this unified administration. So this is a first step in that unified admin tool. We are introducing that with SP10. Primarily what we are providing is using HANA's admin tool, which is called the HANA Cockpit. You have a tile from where you can directly go into Ambari, and you can look at all the nodes that are running in Ambari. So all the stuff that you can do in Ambari, we're trying to provide those as part of the integration for HANA. So for SAP user, if they're already using HANA Cockpit and they're looking at the journey to bring in Hortonworks, they don't have to look at two different UIs, two different applications that an administrator has to use to be able to administer these systems. They can do all those in a single HANA Cockpit layer. And again, it goes back to the reducing the total cost of ownership in terms of having that single experience. And in most cases, they might not even know that they are looking at an Ambari. It might all look and feel like SAP UI. And finally, the tiering to Hadoop. This is something that we are working on, where you want to use this tool called Data Lifecycle Manager, where you define these are the rules based on which I want to push my data from HANA to Hadoop. These rules could be based on time dimension. So you have data that is sitting in HANA for 3 years, and beyond that, all the data is moved into Hadoop. And in some cases, you might want to move the data from Hadoop into HANA for specific use cases. So you have those capabilities as well. I talked about the virtual UDF function. This is primarily how you connect directly to the HDFS files by passing the Hive layer. And few more syntax on how you use this. So for folks who want to try it out, if you have not already done this, all the steps are in here, and we also have the Hana Academy videos where you can pause, go through these steps, and implement that in your environment. Smart data streaming, again, streaming is a capability that is available within HANA. So you have the ability to load the data, load streams of data. So think about IoT scenario, you have data coming from a sensor, or you have data coming from a windmill, and you want to be able to apply specific rules based on which the data is moved either to HANA for real-time processing or to Hadoop for some predictive analytics at a later point of time. So using smart data streaming, you can achieve this where for the real-time data, it's moving that into HANA, and for the other data which is moved into Hadoop, you can build these predictive algorithms. So this is one of the use cases that a customer has where they're using this Lambda architecture, if you will, and on the data that is in Hadoop, they build these predictive algorithms. Since they have that larger data for 10 years or 8 years, they are able to fine-tune those predictive models to a certain extent such that when they apply those predictive models on the real-time data that's coming into HANA, they have a much higher relation to the prediction. What that means is, since you've already trained that model on that large volumes of data, which is in Hadoop, you have a much better prediction when you're applying those models to the real-time data. This is a slide from initially when we introduced the Spark connectivity at Spark Summit last year. Primarily, SAP has its own Apache Spark distribution, not that we've had a lot of traction on that, but some of the things that we are introducing beyond the Odbc or JDBC connectivity to Spark with SP10 and also some of the new projects that we are working on, we have a much tighter integration on the Spark level where we use some of the Spark's distributed query processing capabilities to enable processing of the OLAP capabilities on Hadoop. So just a screenshot of how the Ambari integration looks like, and again, the idea is provide a single layer where you can have the administration capabilities, not just for all the HANA assets, but also for your Hadoop assets that are within the landscape. So switching gears onto the analytics portfolio of products, one of the flagship products that SAP currently has, which has integration to the big data platform, is SAP Lumira. From an analytics standpoint, we have SAP Lumira, which is a data discovery tool, and we also have the BI4 platform. This slide primarily shows how you can use the different platforms from an analytics standpoint, how you can connect to Hadoop, Spark, and also the NoSQL data sources. So with Lumira, you currently have a direct connectivity to Hive. You also have connectivity to Impala, and we are looking at how we can extend that to Drill and other components as well from interactive SQL standpoint. How can you provide the simple visualization on top of the data that you have in Hadoop? And that goes beyond the analytics also to predictive capabilities. So SAP has its own predictive tools like Infinite Insight or predictive analysis tools, and we also have predictive capabilities built in HANA. So these are some of the capabilities that we have. Now again, we can extend some of those predictive libraries that we have in HANA to run on the data which is in Hadoop as well. So in terms of the use cases, I know I have less than a couple of minutes. We have several customers who are taking advantage of these capabilities. A few that you can identify here: utilities customers, NFL from a sporting industry, NBA. Several of these customers are taking advantage of the HANA Hadoop integration. How can I take these two platform capabilities? Running out of time, just a few more use cases. But in conclusion, primarily what we are providing is an integration between the two platforms, how you can bring these two together, make that available for your analytics scenarios. With that, I thank you again for joining this session. I'm going to be available outside if there are any questions. I'd be happy to take.